Okay, so what that means by our inductive hypothesis is that we're going to be able to replace that with the following. We can say that a sub m plus 1 multiplied by p sub m plus p sub m minus 1 over a sub m plus 1 q sub m plus q sub m minus 1, which is exactly c sub m plus 1, which means that it holds for our m plus 1th case. So then by induction, it is true for all cases. Okay, so let's just do one quick example putting this theorem into practice, and then that'll be all that I've got for you. So in this example, show that this is true for c sub 0 through c sub 4, namely for the fraction that we've continued to work with, which is 19 over 51, which again can be written as 0, 2, 1, 2, and 6. Okay, so to begin with, we're going to go ahead and calculate our p values, and then we'll do our q values, and then we'll take those to find our c values. So for the first one, p sub 0, that's just the same as a sub 0, which is 0. P sub 1, then you take your next number, which is 2, multiplied by 0 plus 1, which becomes 1. P sub 2, then, we're going to take our next value in here, which is 1, multiplied by our previous value, which is 1, plus the previous value, which was 0, which just becomes 1. P sub 3, you take 2, multiplied by your previous value, which is 1, plus your previous value is also 1, which gives you a value of 3. And P sub 4, you'll take your next value, which is 6, multiplied by your previous value, plus the previous value from there was 1, which gives you 19. Okay, so there's your p-values. For q-values, we're going to do something kind of similar. Our first value is going to be the number 1. Our next value, q sub 1, is going to be equal to your value in here, which is 2. And then the rest will be defined recursively, so q sub 2. You'll take the next number in here, which is 1, multiplied by 2, plus the previous value, q sub 0 was 1. That gets you 2 plus 1 is 3. And then we'll find q sub 3. That would be taking next number, which is 2, multiplied by your previous value of 3, plus the value that came before that, which was 2. 2 multiplied by 3 plus 2 is 8. And then for our last one, q4, we'll take our next number, which is 6, multiplied by this previous number of 8, plus the value that came before it, which ends up being 51. And then you'll see some familiar numbers starting to show up if you take your values p divided by q. For the first one, you'll get c sub 0 is equal to 0 over 1, which is 0. C sub 1 is going to be taking 1 over 2, which is 1/2. C sub 2 is going to be taking 1 over 3, which is 1/3. C sub 3 is going to be taking 3 over 8. And C sub 4 is going to be 19 over 51. Okay, which are actually the exact same values that we found in our previous example problem all the way up here. But notice that that becomes quite a bit easier work when you've got that formula based on theorem 15.2. If you have any questions, feel free to post on the discussion board. Thank you for your time.